And it's my pleasure to introduce Dr. Juliana Davidoff, and she's going to introduce the panels and take over. Go ahead.
There we go. So it's my pleasure to introduce the three panelists we have today. Bill Barker, who is on the faculty at Bowdoin, Aruj Mabai, who's at ASU, and Paige Williams, who's at Harvard in biostatistics. And they will talk about their very different types of institutions and a little bit about what their research is, but more what it's like to do research at these various constellations. So I'll let you just get started.
Are we starting from left to right?
We
right?
start
Okay.
right to left.
Well, thank you. Thank you for having me here for this panel. I'm Anuj Mobai from Arizona State University. We are having multiple programs that we run in our department. One is called Mathematical Theoretical Biology Institute, MTBI, which is a summer research experience for undergraduates. There is a reason why I'm bringing these things, and I will give you the connection between many of the programs that we do. Also, we have an Applied Mathematics in Life and Social Sciences program, which is a graduate program, both at master's and PhD level. Well, my personal area has been working in neglected tropical diseases. Well, you will be amazed to listen to this particular topic that I'm talking about, is neglected tropical diseases. Well, I'm an applied mathematics training. I have an applied mathematics training by one of the prominent mathematical biologists in the field named Dr. Carlos Castillo Chavez. But since then, I have been working in very interdisciplinary fields. Well, what we train in our program is applied mathematics as a tool to address many issues of your interest rather than my interest. So for example, some of the work that students work on are related to sustainability, related to ecology stuff, and they are all using cutting edge tools for coming from mathematical techniques. And that could include broadly as stochastic processes or computational sciences or statistics in general. So I'll end here, and maybe as we go along, I'll describe again all these things in more detail.
Okay. Good afternoon, everyone. I'm Paige Williams. I'm the Director of Graduate Studies for Harvard University Department of Biostatistics. We have a PhD program in biostatistics that allows students to specialize either in biostatistics or bioinformatics. And bioinformatics, the students tend to be more focused on computational biology or high-dimensional data with a lot of computing applications. We also have 4 master's degree programs. We have a regular master's degree program that runs 2 years. We have applied master's degree program. We have a new health data sciences. Data science, of course, is the big buzzword. Everyone is doing data science. But ours is specifically focused on applications for health research. And then we also have a computational biology and quantitative genomics master's degree program. Just to give a little bit of a flavor, the sort of research that faculty members do in our department varies widely, and I think that it sort of mirrors their own interests, ranging from fairly theoretical statistics and causal inference methods, people who really are developing new theoretical approaches, to very applied research. And I put myself at the applied end of the spectrum. I still really love analyzing data and working on collaborations. And I think by its nature, biostatistics is always collaborative. And I think that's one of the nice things about it, because you're always learning from your collaborators more about the fields that they're working in. And that makes it really interesting. I think it's stimulating to know that I'll always be learning. Maybe not new statistical methods, although hopefully some of those too, but more about reproductive health, more about nutrition, more about cardiology. I won't become an expert in any of those areas, but it's nice to learn a little bit about them. So I just want to give a flavor of two different areas that I work in. I co-lead a program looking at pediatric HIV research. And I have two cohorts that I oversee. They're US and Puerto Rico-based cohorts. One is evaluating children who were born with HIV. Most of those children are now adolescents and becoming young adults and transitioning to becoming independent. And we're evaluating all sorts of issues as they deal with that transition in terms of their metabolic health, psychological health, their own sexual activity and reproductive health. So that's one group. And the other group are babies that are born to mothers with HIV, and we're studying the safety of drugs that are given to mothers to prevent their babies becoming HIV infected. And so there ends up being a lot of very interesting statistical problems as a result. That cohort is now about 4,000 mothers and their infants and children that we're following, hopefully until they're adults. So that's some of the type of collaborative research I do, and I work with a team of 15 to 20 master's level statisticians, PhD level statisticians, and epidemiologists. So it's a real sort of team project. And in a different area, I work in reproductive health in relation to environmental exposures. And I've been working with a large cohort of in vitro fertilization studies. So these are studies evaluating couples who are undergoing fertility treatment. And because of that, they're giving lots of urine samples, the women are, to see if they're pregnant or not. And we use some of the extra urine to test for chemical exposures to things that everyone in the US is exposed to, things like bisphenol A, phthalates, triclosan. Triclosan is used in like antibacterial soap products, toothpaste, et cetera. And we want to see if women who are exposed to the higher levels of those types of widespread chemicals have any difference in their ability to have a live birth through fertility treatment. So that also has very interesting statistical issues because there's clustered data. We get to observe the individual oocytes maturing. Once they mature and fertilize, we can see if there's implantation. So there's clustered data, informative data, imbalance clustering. And it's really, again, an interesting, stimulating, collaborative group. It's sort of a team project. So those are the type of research studies that as a biostatistics researcher myself, I'm involved in. And I think it makes the work that we do really interesting to learn about these other areas as well.
Oh, wrong way. Thank you. Hi, everyone. I'm Bill Balker from Bowdoin College. I am a theoretical mathematician. I was intending to write a thesis in functional analysis or probability when I ran into a Lie group in graduate studies and all its associated structures. I fell in love with it, and I ended up writing a thesis centered on analysis on Lie groups. After a 2-year postdoc, I was appointed at Bowdoin, where I have been for well over 40 years. So I guess I'm not going to get fired, at least not yet. The Bowdoin, if you don't know about it, it's a small 4-year liberal arts college on the Maine coast. It was founded in 1794, and the following is true. One of its purposes of being founded was so that the students of Maine did not have to go through the hardship of getting their college degree at Harvard. True. It's an elite and very well endowed college. We have 1,700 students approximately, and over $1 billion endowment. That is $1 billion, so not, with a B. Hence the point of that, there is exceptional support for faculty research. First of all, the teaching load is just 2 courses a semester and 2 semesters a year. There is truly generous support for research and travel. And it is particularly generous sabbatical program, which even includes a sabbatical for junior faculty before they come up for tenure, so that they can better prepare themselves for the tenure decision. Yes, research and scholarship is highly active in this environment. My own focus has shifted over the years. As I said, I was working with analysis on Lie theory in Lie groups. I then actually became very active in the calculus reform movement in the 1990s, and more recently have been involved in classical geometry, both scholarship and textbook writing in that area. Bowdoin is very supportive of these forms of professional activity and research. So what do we lack? Well, collaborators right at Bowdoin, in the sense that it's not really possible for us to have more than one person in any particular mathematical field. On the other hand, with the internet, with Skype, with the travel support that we supply, and with the sabbatical policy, it's not at all hard to have plenty of collaborators outside of the college, and most of our faculty are in that situation. The point is that the opportunities for research are very good in this kind of a college. The situation is, of course, tighter in institutions that aren't as lucky to have this kind of endowment backing. And we can talk more about that during the question and answer period. Thank you.
So we should open it up to questions that students might have about, those of you who are thinking about going into the, as all of you are, I'm sure, thinking about going into the job market, and what kind of institution would nurture your own ambitions in mathematics and the mathematical sciences. They are very differently configured institutions. Or you could add any of you could add anything you want to.
Well, I want to add some things after listening to my panelists here. Well, there are lots of programs here in the nation that are offering applied mathematics. And actually, the topic of this panel discussion is on the choice of your research, right? So, well, how do we find the research areas, and how do we work on it? Well, in our program, and I'll give you an example of the programs that I'm heading or I'm part of. Well, for example, the research experience for undergraduate, which is an undergraduate program, and we do the same thing in a graduate program also. And the reason I'm giving an example of an undergraduate, because it's a short, but we can even do it in a short program, then definitely we are implementing it successfully in the PhD program as well. So the choice of the research that the students choose in the MTBI program is through their interest. Well, we have this terminology, we call it as flipped hierarchy. What that means is that students are the drivers of the project. What that means is if the interest or the application of the project or research is coming from the students, then faculty mentors are not that much aware of that applications, and that becomes truly a student-driven project. And that is very, very difficult, because from a faculty perspective, how do you guide it? And for that, we have a multi-discipline faculty in our department which assist in designing a viable research questions with the help of students. Of course, the students are the one who are reading more on that particular topic that they are interested in working, but that is where the faculty is helping them design novel scientific question, and that eventually becomes their research project, which is very, very critical. If you have your interest coming out on your research, you are more likely to end up using that research background for a long period of time. And this is what we adhere to in our PhD programs or in our master's program. And all of them are research-oriented programs. One of the other critical thing in our program is that we don't grade anything, we evaluate things. Let me explain what that means. For example, we do not have qualifying and comprehensive exams in our PhD programs, just like, well, I did the qualifying and comprehensive exam when I was in my PhD program. Well, that was 5 hours exam, and there were just 2 chances that you could give, otherwise you are out of the program. Well, the way we do it, little different, and actually it helps the students in their long run and building their CV. So for example, in qualifying exam, they are expected to produce 2 manuscripts of their own interest, research manuscript. And that helps in 2 ways. They have to do it in 2 years, because qualifying exams, they are supposed to do it in 2 years. And when they do it, these 2 research manuscripts, they are getting an idea about their own research. What do they want to do as a PhD dissertation, for examples? And that is what I mean by saying our program is very different than many programs in the nation, is that we evaluate their work. Of course, we critically evaluate their everything, but those things are not graded. Some of the students are very afraid of giving an exam in a classroom. But that doesn't mean that a student is not capable of performing well in the research. And that is the idea behind this type of process to do in the program. So I'll stop and I'll talk again on various ends that we do in our program, which is little different, and I'll give opportunity to others.
Okay, well, I think that's a nice topic to sort of talk about here, is how do students get engaged in research? And I think in our department, when students start the doctoral program in biostatistics, some of them may come in already knowing they want to work on statistical genetics or they want to work on network analysis, but most of them really aren't quite sure what they want to do. And that's okay. I mean, I think a lot of students in our department come in thinking, I think I'm interested in biostatistics, but I'm not sure exactly what yet. And the first semester they take courses, and then over the winter they do a very short sort of independent research project for a couple weeks with the faculty, and that can be reading papers or maybe doing a little data analysis or coming to lab meetings. It's really what the student wants to do. But then in the summer, after their first year, they have to do a 10-week project where they work one-on-one with a faculty member. And that may not be the person that they end up doing their dissertation research with, but we think it's important for the students to get a chance to participate in that kind of research process fairly early on, and not just be in classrooms, because really you want to expand to understand what kind of things might I actually be doing if I go into this field. So all of the students do a research project over the summer. They organize and structure it themselves with their faculty advisor, and then at the end of the summer they give a short presentation on that. And so that's sort of their first step into the research process. After that, some students might continue just to follow up on their summer project and write their first paper on that, or start doing rotations where they work with different faculty members to get an idea of what different topics in the field are. And one of the ways that they find out about those topics is we have a very active seminar program and working groups in different areas, and students participate. They're really aimed at sort of the level of the doctoral students and master's students, so that they can have a sense of what are faculty in our department actively working on and what are some of the research gaps. Because until you understand a little bit about some of the areas, you don't really know where the hot topics are, what areas really need more innovation in terms of statistical methods. So that's one of the ways that students in our department start getting a sense of what are the types of topics people working on, what are the areas where there needs to be more research, and what things appeal to them. And so that's sort of the initial process over the first few years. And we do actually have a qualifying exam, a written qualifying exam. We've talked about abolishing that. The faculty have very strong opinions on both sides of the coin. And you know, I think there's been a movement to even stop requiring GRE scores for lots of graduate applications. So I think that's a trend that's going to continue, and we may at some point discontinue having a written qualifying exam. But in our department, once students pass that exam in their second year, and actually usually 95% or so pass, it's not a thing that we use to try to weed students out. Then they can choose their dissertation advisor and really start working more of their time on research rather than the classes. The first 2 years, though, are really primarily coursework in our department.
Since Bowdoin is a four-year liberal arts college, we do not have graduate students. So talking about what they do at Bowdoin is very easy. Mainly, we don't have any. So.
Well, I want to add a couple of points. First of all, the department that I'm part of has faculty from multiple departments, disciplines, I would say. For example, epidemiology. For example, network science, biostatistics, sustainability, anthropology. So it is much easier, and Arizona State University is heading in that direction where schools are problem-driven rather than discipline-driven. And that is very important because in today's world, any real-life problems cannot be solved by one discipline. It is solved by, you need tools from many different disciplines. And that is the ideology there, to constitute these departments which are very interdisciplinary at the interface of the problems rather than at the department level. Second point that I want to make, and therefore it is easier for a faculty to actually, for many faculty to be part of person's research career. Okay. Second point I want to make is that we focus on something we call it as, there's a very common term in medicine which is called personalized medicine. What that means is that you are giving a medicine to a personal level, knowing the historical perspective of that individual, or knowing many things that is very particular about that person rather than general. For example, many times vaccination or treatment programs are designed based on majority of success, right? That doesn't mean that it helps to all of the people in the population, but majority. So there are some people who are left out in that. And so what we focus on is a tailored program designed for a particular person interest. So for example, the courseworks are designed in the way that person interests are. Or the research projects that they want to do, they are exposed to those type of classroom exercise, or to the people who will be more favorable to the interest of that individual. That's it. Thank you. Well, definitely, that should be the one of the things. Also, in graduate schools, many times, reality is different than actually what many. For example, the research area that I work on right now, I never thought that I will be working in this discipline before. So some things you can plan, some things it comes to your way as you progress. Well, in the graduate program, it is very important to choose a correct mentor, which would be helpful to you in a way that help you to choose a right research path, And not only this, but good mentors are actually mentor for a life. And they just don't leave you at the time that when you graduate, but stick to you forever. And I have been very lucky in that regard that I have mentors who I bother them all the time. And all the time I mean every month, which is not like I'm asking every day where should I buy my grocery from, but on a regular basis. And this is very critical because as a students we are not aware of lot of things that are changing over a period of time, and mentors are a right way to help you guide in that way. So for example, the field that was very popular 5 years ago is not popular now. For example, there wasn't anything called as data science a decade ago, but now it is one of the most important one. And so from a mathematics department perspective, we have to change a little bit to tailor students to provide a skill set that could help them get to today's job. It could be academia, it could be even industry. It's a choice of a student where the person wants to go. I don't know if I've answered you, but I've given you a kind of broader perspective on it.
So you also mentioned that the general trend that I guess academia is going is rather than being discipline driven, that it's problem driven. So should that be something that this, I guess, generation should take into account as opposed to what you guys would, or how big of
Well, I will not say yes or no, but as she was mentioning, well, as she was mentioning, there are only a handful of the departments or the programs that have changed as the requirements in the job markets are changing, because there are lots of resistance from individuals who have their. So, for example, my area is dynamical system bifurcation analysis. I don't want all my students to come and work in that area, because if it is problem driven, you cannot use the same tool. It has to be, if it is a problem driven, it could be optimization you might use, you could use topological spaces, you could use many different types of mathematical techniques, even statistics. How to choose program, that's one thing you did, guys, all of you guys did a wonderful thing, is by attending this Math Alliance conference. Well, this is the place where you get to know what is the way the departments are thinking, right? And it is very hard to know all the ins and outs of it until you go and be part of it, right? I can tell you about some of the schools that I am aware of that they have changed quite drastically. It has been very difficult, but we have changed, and Arizona State is one of it, in that directions where disciplines are there, but more like we focus on problem-driven approaches. Yeah.
Any other questions? Wait. Hold.
Yes, loud and clear.
Okay, so what I feel like I keep hearing is to find what kind of field of research you might be interested in is to look in and learn about more and more fields of research. But I would consider myself very agreeable, and even today I keep learning about these things and think, oh, that would be so cool to follow up in research. So what are some ways that you might advise someone to narrow down those interests to find somewhere to focus?
I think that's a pretty tough question because there's so many opportunities and there's so many different areas that are compelling. And I also felt the same way, like I would have just been as happy doing this or doing that. I started out working on a lot of clinical trials and then moved to doing more statistical work on observational studies. I like both. Some people don't really mind what they do as long as it's interesting. But I also think that when you're thinking about where you might want to go and pursue your own doctoral studies, you have to think about the size of the department, the environment of the department, whether it's in a big research university or a smaller liberal arts university. I think from my perspective, at Harvard, we have a huge department, and it's not the right fit for all students. I mean, I think some students come and just feel a little bit lost there because it's such a big place. And so I think for the size of our department, it's good for students who are fairly assertive and have a lot of self-confidence, and they may not know exactly what they want to do, but they feel confident that they're going to find something. And other students, I think, might feel much more nurtured and supported if they're in a smaller, more close-knit department. So I think you need to think not only about what type of research you're going to do, but where you feel like you fit best. You know, and I think a lot of that is sort of intangible. It's hard to know without actually going and visiting places, and sometimes it takes some legwork to actually either make attempts to contact faculty, hopefully they'll respond to you, either talk by phone with them, or go and visit the different departments if there's any opportunity to do that. But I think a lot of it is sort of your gut feeling of whether it's the right place for you. And then, you know, there's other issues that of course come into it. Financial support is a big one. Most master's degree programs don't usually fund students, or it's fairly rare to have that kind of funding for a master's degree program. A lot of the doctoral programs do, but they require part-time work. And so you have to think that, you know, factor that into, are you going to be able to juggle having the responsibilities of work, which is also something that can really benefit you in terms of broadening your experience, but it does, you know, make you have a full schedule. So I think those are some of the other things. I'm sure the other panelists can think of other things too, but it's a complicated decision, I think, because it's not just about one thing that you want to study, but because there's lots of places you could go, but finding the right fit for you.
In terms of actually picking a field where you'd like to get a doctoral degree in, the one piece of advice I like to give to people, to our students, is to not commit too soon and be open to other possibilities. And what I mean by that, at least with myself, I mentioned I was going to do functional analysis, probability, and one thing I knew I didn't want to do was anything that dealt with algebra and groups and stuff like that, because I just didn't like them. I just didn't. And then I ran into one. I had to work on this one particular paper, Brownian motion on Riemannian manifolds. And in the middle of it, it said, and then because the group of isometries is a Lie group, you can do the following unintelligible thing at the time. And so I was really quite disturbed that, all right, this is the end of my second year of graduate work. Okay, let me try to figure out what this group thing is. Within a month, I had switched. And that summer, I asked one of the Lie theory experts at my institution, would he please have me as his student? And 2 years later, I got a degree in Lie theory and have never regretted it. The point is that sometimes something you may think you don't like may in fact be the thing that turns out to be your mathematical love in life. Certainly Lie theory has been that for me. Thank you.
Okay, that's it. Go ahead.
Are there questions? Other
One
questions?
question there.
Over here?
That's it.
So I was thinking about doing statistics and more precisely something maybe in machine learning. But since you were saying about switching during your graduate work, how closely related are all the statistics fields? Like let's say I was doing machine learning, but then at the last minute I wanted to do biostats. How would I have to go back a few years, or are they close enough related where I can just keep going?
Well, I can talk about a project that I'm currently working on, and let me say something very quickly before I come back to your answer to some. Well, among you all, there is two students, Alejandra and Luis, sitting there. They were part of 2018 MTBI program, so you want to talk to them if you want to know about the programs at Arizona State University. Also, we have a table right after this at an REU fair on top. We have a graduate program also there. This is an advertisement, sorry. Coming back to your to response to your question. So I'm working on a project which is studying mapping dengue prevalence in Latin America. Mapping dengue prevalence. Now you will wonder why I'm doing that thing and it's a massive project because there are 7-8 researchers involved and different countries are also involved. So the project, it is important because reported data is always highly underreported from these countries. And if you base all your interventions based on reported data, that would likely to not work. Okay. So what we are trying to do is, okay, so, and these are resource limited countries, so you cannot collect the data. So you can do little bit better job, but not to the best of the job. So what can you do then? So, well, we are using an alternative source of informations, and we are mixing multiple disciplines again. So we use data mining. So we are mining the data from social media and Google searches to study the symptoms prevalence in the communities of different countries, Latin America. And then we are using a transportation network data or models to design how the people are moving, because the moving behavior are very critical for dengue outbreaks to go into new places or spread quickly. And then the third thing we are using is an epidemic model, which is a dynamical system differential equations type of models. So, and we are using all these things and connecting it to design a framework where we can give a global map or Latin America map for dengue prevalence over time, in a real time. So your question was how important it is or how quickly we can change. Well, the point I'm trying to make here is real problems are not method-based. You have to learn in today's job market multiple skill set. Programming is must, statistics is must, and I support her on many of these things that she mentioned here. But also your interest is must. That should design your research field. And if you feel like this is the topic I want to work on, you could always find tools that are mathematicals or statistical or all of the following to work on that problem. So it is important to identify first your research interest, but changing tools are just a matter of time that you can learn many of these skill set in much details. Okay.
Paige, did you want to address that also?
Yeah, I think just to add to that, I think in our doctoral program, all students have to take 4 core courses, the same ones, and they're really the foundation courses for statistical inference and probability and methods. And then after that, they get a choice of whatever courses they want to take that are considered the more advanced courses. And we do have courses in machine learning. Some students actually go over to take courses at MIT or in the main computer science department, applied math, the statistics, and those all can count towards their requirements. And students do sometimes change gear. I mean, sometimes they start out thinking they want to work in one area and then transition, but at least the coursework that they've taken will count. And they will have, again, brought in their skill set in learning those different areas. But I think that issue, it comes up even for faculty. I think faculty start working in one area and then become totally excited about a completely new area, and they have to learn some skills just to make headway in that new field. One of the former chairs of our department, Nan Laird, is known for developing growth curve models and mixed effect models. And then in the latter part of her career, she really became interested in statistical genetics. And that was completely new to her, and she had to, again, develop the skill set to work in that area. So I think whether you're a student or faculty, or even if you've been in the field for 30 years like I have, you do change over time in what your interest and the topics, and that's what makes our jobs interesting. I think when you have that really strong quantitative training, you know that you can learn these new areas because you've got the foundation. So I think laying the foundation is important, and being open, like you said, to changing over time. That's a natural progression, I think.
Other questions?
So all three of you have mentioned doing research either at the doctoral or in a professorial role while at your respective universities. But for those of us who are still in our undergraduate, how might we get involved with doing more research? I know that the REU programs are always a great vector for doing so, but are there other programs that we should be looking for, some other ways of contacting professors, like just emailing them if they're in a field that looks interesting to us? How should we try and get more involved, really?
I guess my own hunch is that going to some of these like SIBS programs and RUs is probably the best way to do it, because they're a little bit more structured, and they actually put effort and incentive into the faculty to mentor the students in them. I think if you have a specific thing you're really excited about, and you want to email a faculty member to see if they might be willing to do research with you, try it. But I know in my own university that the faculty sometimes get pretty maxed out because they're mentoring all the students in their practicums, and it's hard for them to take other students on, especially if they're not locally. Face-to-face research, I think there's something to be said for that, at least getting things started. So I would say if you have something you're really excited and passionate about, try it. Be assertive. See if you can get some headway. But my guess is that the most sort of likely way that you're going to get those chances is through these structured programs like the SIBS programs and REU programs.
There are some institutions that have their own money for support during the summers. I, of course, don't know whether that's the case in yours. I know Bowdoin has an amazing amount. I've been really surprised, and we didn't have really much of anything about 25 years ago. And now a lot of students stay over the summer doing research. I might also mention, you said REU, the only other program I'm aware of, that I'm very aware of, is the Park City Math Institute. I don't know if you're familiar with that. It's a 3-week program at Park City every July, essentially, late June, early July. It is an amazing program. It involves every component of the mathematics community. I mean, every component in both separate and integrated programs together. At any rate, it's quite the experience. A lot of graduate students go, but there is an undergraduate component that's truly wonderful. So look into that. It's not quite research, but it's pretty close.
How many of you have heard about SAMC or NIMBOYS? Or, okay. Well, you should ask also Alejandra, Luis, and Daniel. Can you guys raise your hand, please? Yes, these guys. They have been part of many of these. And there are certain institutes in the nations that are established by NSF, National Science Foundations, that are working in mathematical sciences, and Park City is one of it. But there are others also, like IPAM at UCLA, IPAM at UCLA, NIMBOYS, which is at Tennessee, University of Tennessee at Knoxville, and MBI, Mathematical Biology Institute or Bioscience Institute at Ohio State, SAMC at actually it's not at any institute, but it is in a research triangle park in North Carolina. So these are, and there are many others also. I am kind of forgetting, but these are, they organize many undergraduate workshops. Now, that is a short workshops, but it is very critical for you to know what are the areas people have been working on, right? And this is very important for you at that early stage. And these are undergraduate workshops that I'm talking about. Even they have graduate ones also, but they have undergraduate ones. And many times, many of the faculty or mentors coming there for those workshops are actually okay for you to work with them on research topic of their own interest, of mutually agreed interest, through Skype or Google Hangout, for example, on a regular basis. And just to tell you, I have been guiding students like that, many of those ones, in the past or currently also. And so also Math Alliance has a list of mentors that you can approach and see if they are willing to help you remotely to work on things that interest you. Right? But foremost, you have to know what interests you. What are the potential places or research areas that you want to devote your time in?
Other questions? Other comments?
We have been talking a lot. Well, don't forget to come to our table, and we will have undergraduate as well as graduate programs in IDU Fair upstairs after this.
It's after this
Yeah,
session.
this is-
Thank you all. If you have any questions, you have resources back there and our panelists as well.
I'd like to thank the panelists.